Alrighty, boys and girls, welcome to our fourth video lesson in Chapter 8, continuing our saga into the world of sequences and series and summations and other such and assorted things. We're gonna call it 8-4 old, kind of like me, old. Alrighty, in this lesson we're gonna learn how to find the rule for power series, or series that aren't geometric, they're not arithmetic, they're power series. They're like polynomial functions. Okay? We're going to do that by subtracting our terms. We call the differences when I subtract the terms of a sequence, the consecutive terms of a sequence, the first differences. My second differences are going to be the differences of the first differences. Rocket science, huh? And the third differences are going to be the differences of the second differences. Yes, the fourth differences would be the differences of the third differences. We're going to use differences now to find the rule for a power series. In other words, if we look here, n equals 1, 2, 3. This is a table where this is my term number, so my first term, second term, third term, etc. of this series right here. A sub n is 1, a sub 2 is 8, a sub 3 is 27, a sub 4 is 64. Do you see the pattern here? A sub 5 is 25. In other words, each of these numbers is the n to the third power. In other words, this is a sub 1 is 1 to the third, a sub 2 is 2 to the third, a sub 3 is 3 to the third, 4 to the third, 5 to the third, 6 to the third, 7 to the third. If I subtract 8 minus 1, I get 7. 27 minus 8, I get 19. 64 minus 27, I get 37, etc. These are my first differences. My second differences, now I'm going to subtract 19 minus 7, I get 12. 37 minus 19, I get 18. 61 minus 37, I get 24, etc. My third difference is I'm going to subtract 18 minus 12, I get 6. 24 minus 18, I get 6. 30 minus 24, I get 6, etc. I can see now that my third differences are all the same, so I know that this was a third power sequence. And sure enough, it was a third power sequence, because this is n to the third, 1 to the third, 2 to the third, 3 to the third, etc. Now that we know it was a third power sequence, if I had a graphing calculator, I could input my terms and do a third power regression, or if you want, a cubic regression to find my rule. If it were a fifth power, I could do a quintic regression. If it were a second power, I would do a quadratic regression, etc. Okay, the summation formulas for each of our power sequences are as follows. I'm not going to make you memorize these. I will give you these formulas if you need them. We will also derive them in class. It's actually pretty cool. Okay, but we're going to look at our first one. N equals 1 to n of a first power series. So it's just rule is n, so it's 1 plus 2 plus 3 plus 4 all the way up to n is n times n plus 1 over 2. Our second power summation, or series, so the summation for n squared from 1 to n is going to be 1 squared plus 2 squared plus 3 squared all the way up to n squared. Here's our formula. The third power, so we're going to do 1 to the third plus 2 to the third plus 3 to the third all the way up to n to the third is right here. Our fourth power, 1 to the fourth plus 2 to the fourth plus 3 to the fourth, all the way up to n to the fourth, etc. And our fifth power is here. They do go on forever, but we'll stop right there. Alrighty, let's find the sum of the 8 terms of an n to the fourth power sequence. So in other words, when I say let's find the sum of the first 8 terms of n to the fourth, that's saying 1 to the fourth, plus 2 to the fourth, which is 16, plus 3 to the fourth, which is 81, plus 4 to the fourth, which, don't tell me, 256, plus 5 to the fourth, which is 625, plus 7 to the fourth, plus 8 to the fourth, etc. I don't know 7 to the fourth, plus 8 to the fourth. that is going to add up to something. Well, we can use our formula now to figure this out. Of course, I would start with the hardest one, but the formula for a fourth power series or summation is going to be n to the fourth is equal to n times n plus 1 times 2n plus 1 times 3n squared plus 3n minus 1, all divided by 30. All we're going to simply quite do now is replace n with 8. So this is going to equal, n is 8 times 8 plus 1, which is 9, times 2n plus 1, which is 16, plus 1 is 17. And I'm going to do this work up here, and now n is 8, so I'm going to have 3 times 8 squared, which is 64, plus 3 times 8, which is 24, minus 1. I'm going to pull out my calc real quick. 3 times 64 is 192, plus 24. 216 minus 1 is 215, all divided by 30. Okay, because I can and because it's fun, before I multiply and divide, I'm going to do some canceling. 5 goes into 30 6 times. 5 goes into 215 43 times. 2 goes into 6 3 times. 2 goes into 8 4 times. And 3 goes into 3 1 time. And 3 goes into 9 3 times. So now my sum is going to equal 4 times 3, which is 12, times 17, times 43. And that equals, this sum is equal to 8772. And we can always check that on our graphing calculators to see if we get the right answer. Okay, again, now we're going to find the sum of a third power series, the sum of the sequence, the third power sequence. So we're going to find the series, a third power series. So we have 1 to the third, plus 8, 2 to the third, plus 3 to the third, which is 27, plus 4 to the third, which is 64, all the way up to 10 to the third, which of course is 1,000. So we're going to just use our formula instead of adding all those numbers up. So the third power formula is equal to n squared times n plus 1 squared divided by 4. It's much simpler than the fourth power. So now we just replace n with 10. Let me switch colors. So n is 10, so that's 10 squared, which is 100, times 10 plus 1 is 11. 11 squared is 121, all divided by 4. Before I multiply, I'm going to cancel. 4 and 100 is 25. So just whip out my calc here. 25 times 121. I get 3025. Okay, you guys can try this one, but remember, we're going to add now n squareds all the way up to 15 squared. So 1 squared plus 2 squared plus 3 squared plus 4 squared, all the way up to 15 squared, which we know is 225. So there's 15 terms. You're going to use the formula. So the n squared power series is equal to n times n plus 1 times 2n plus 1 divided by 6. Go ahead and stop the tape and give it a go. Okay, you should have gotten 1240. What I did is I replaced n with 15. So I had 15 times 15 plus 1 times 30 plus 1, 2 times 15 plus 1, all divided by 6. I then canceled a 3 out of both the 6 and the 15 to get 5, and I canceled the 2 that was left over with the 16 to get 8, and so I had 1 down at the bottom. So then I quite simply did 5 times 8 times 31 is equal to 1240. How did you do?